Kia ora, Andre here. Welcome back to Killer Drones. Today we have got the Launch RC Vulcan. This little frame has won me over. I'm smitten with it. It's nice and stiff, it's light, and importantly, it looks super cool, don't you think? Oh yeah. So, this part 1 build, what we're going to be doing is we're going to show you what's gone into the Launch RC Vulcan, all its components that I put on it. There's also some facts and figures hidden into a build montage that's in part 1. We'll get to the point where it's fired up and it's power running through it. Part 2, what we'll do is we'll be taking it outside, flying it around, smashing some packs through it, and seeing the performance of what I've put together here. Alright, let's not muck around, let's get on with it. Alrighty, so here it is. This is going to be the build. So we have the Launch RC Vulcan pod drone here. As you can see, comes with 4 arms, and it has this base plate and top plate which interlock together with these little studs to hold everything together, and then we have this pod that's going to be going on top. For our FPV camera, we're going to be having a Foxeer Arrow 3. We'll pull that off, there we go. That's going to be quite nice. Heard good things about these, so I'm really interested to give it a go. And this is the one that comes with is the 2.5mm lens. It's going to be pretty cool. To display that, what we're going to be running is a Eachine TX03, 72 channels. It's going to be interesting to see what the performance of this is like. It's super mini, super light, and we're going to see how good it produces our feed back to our goggles. Alright, getting down towards the business, we have these suckers. These are the RCX brushless motor, the RS2206. These are 2400 kV, and these are the V3s, the latest ones you can get. They look pretty nice, pretty smooth. They feel like they might be pretty grunty, so expecting good things from these, so we will see what they're like. Powering those, we're going to be having these Hobbywing XRotor 30 amp ESCs. I think there might be a newer version of these, but yeah, we'll see how they go. Alright, so moving on down for our flight controller, the next big piece, we have an Omnibus V3 Flip 32. Pretty excited about this. This is a current sensing, can run your FPV through here, so your camera and your VTX to get your OSD coming out. So that's going to be pretty exciting, see how that all works together. So everything's soldered on for a nice lightweight build. How are we going to be powering this thing? I've picked up this Matek hub, 140 amp rated, so that's going to have plenty enough power for running these ESCs over here and these grunty ass motors. And to top it all off, super micro free sky receiver. Okay, so let's get on with the build. So there's a pretty good video that the Launch RC guys have put together for the Vulcan build, so if you want to get all the detail, just head over to their channel and have a gaze. It's pretty easy. The arms are sandwiched together between the 2 X plates. Just make sure that the pointy bit goes towards the middle. Then you screw from the bottom of the base plate into the arm and into the top plate where these press nuts are. Then just carry on with the other 3, until with the power of jump cuts, you're done! So with this frame, it doesn't really matter which is front and back. You can decide which way you want it to go later on when it comes to putting on the pod. Righty ho, so let's see what it weighs with this base plate. What do we get? 64 grams. And with the pod and the nuts, we get 92. That's pretty good. Under 100 for a 4mm carbon frame. Sweet. Okay, let's get out the motors. So these are the 2206 RCX motors. They look the business. I'm really loving the matte black and the red. I have noticed that the wire comes out of the motors here at a funny angle. You just need to carefully manipulate it. Don't push too hard, but no biggie. And again, so let's check out the weight. What have we got? So just with the motor itself with its long wires, let's have a look. 34 grams, and with the screws here, 36, so half a gram each.
Okay, before mounting the motors, let's check out the carbon bits. So very nice. 0.3mm tolerance there, and it's all 4mm. 0.9 across the arm, that one, okay. And what we got, yeah, 0.3. And the final, only 0.2. Oh, nice. And the central there, 1.9. So it's 2mm carbon. Pretty good. Righto, so let's crack on with the motors. Just carefully take that wire, fix into the frame. So I'm not going to Loctite right now. Just the first step to see how everything's going to be mounted together. So the frame, the carbon's cut by the look of it, so that if you have a frontal impact just here, it means that the motors won't get hit with this little bit that protrudes out. It's quite a smart idea. Sweet, so that's one motor. On to the rest. So these motors feel pretty smooth. I can't feel anything adverse in the barrel there. So, okay, so here we are, the motors are on. Just working out how the ESCs are going to sit on the arms. That way we can just cut the wires to length nicely. Just give them a bit of a mark where I need to cut. And snip them off. Next step is to go and just tin all the pads for the ESCs and tin the pads on the distribution board, the power board that is. And also, just make sure you tin those motor wires too. I've kept my motors all nicely together, so I know which one's which, the way I laid them up before, so that when I go to put them back on, they're all going to line up nicely. Okay, next is just soldering the motor wires to the ESCs. Remember to solder the wires correctly onto the ESCs so that they spin in the right direction. The easy rule I follow is just wires that go straight on to the ESC, that makes it go clockwise, and crossing over the two outside ones makes it spin counterclockwise. Easy peasy. All done. Now I like to pop a little tab of insulation tape just under the ESC pads. Carbon fibre is conductive and I don't really want any shorting. That would be a problem. Solder the ESC positive and the ground wires to the PDB. Just holding it with the screwdriver here, don't want to get my fingies burnt. And time for the battery connector pigtails. Measure and cut them. And solder them to the board after you've tinned the wires. Righty-ho. So at this step, with the multimeter, I go across all the points, just making sure that the positives have continuity, and also that the grounds and the positives are not shorting across each other in any location. So I'll just go through and do all that, and then we'll come back. It's all looking alright for me. Okay, so now we can move on to the flight controller. So just tin all the points on the flight controller that I'm going to be using. So here I'm just soldering onto the points which the receiver is going to go into. Try not to solder across bridges or try to bridge anything. And then we're just soldering on the S-bus receiver wires onto the board, which I'll also do with the ECS wires later on in the build. But let's cut to the final end. Alright, so here we are with the build, essentially ready for testing and plugging into Betaflight and all that guff. So what I've done, you can see here, I've got the camera mounted in here and I've got my VTX all ready to go. That's going straight into my board here, so it's got the OSD built into this V3 Flip 32. And what I've done is, so I can disconnect and connect the power with the battery still plugged in, so I'm not powering my VTX, I've soldered in the wire with a little connector here so we can plug that in and away we go whenever I need it. Now, voltmeter with my continuity checker as I go through and just check that positive doesn't reach any of the negatives. In here, look around, so that's a ground one there, it's not beeping, which is good. So I've done that at each stage, so I've done that on the power board under here, and I've done that for all my connections on top of here as well. And they all seem to be not connecting across them, so we should have no shorts. But as a failsafe, I've also used my smoke stopper here. The way I've rigged mine is I've got two plugs. This one goes into the copter, like so. And then either one of these powers each one of those filaments. So when I'm testing the board alone, I'll plug in my 5-volt one, and if I'm going to power my motors, I'll plug in the big sucker. And the theory is that if there's any shorts, the power will go through here and the battery will light up. As well, if there's any draw, the light will light up based on how much draw there is. So the moment of truth, got the shakes. They haven't plugged this in yet, so let's going to see how it goes. So I'm going to plug it into the 5-volt, and as the motors beep and make their chirps, hopefully they make their chirps, the light will come on, and then hopefully it doesn't stay on. Alright, 3, 2, 1, let's see. Ooh. Ooh. And no more lighting, so the chirps draw a bit of power. That was it. So, no smoke, no issues. I can see a light flashing on here, which means the receiver has got power. And if we plug in the VTX here, let's see if that's got power. Oh, look at that. That even has power. So, everything's looking good. So, right now, let's go and plug it into Betaflight, or Betaflight if in New Zealand, Betaflight if in America, one of those two, and let's do the programming and get ready to fly.
So there we have it. It's built. We're going to go out there and fly it. So make sure you like this video and subscribe to catch part 2 of when we go out and fly this thing around. Also, over the next few weeks, we're going to be reviewing individual components that have gone into this build. So that's going to be pretty exciting. Make sure you drop me some comments in the bottom if there's anything in particular that you'd like to see me review first. Rightio, until next time, bye!